When we look up at the night sky and let our eyes wander across those shimmering stars, it's easy to feel small, but also deeply connected to something vast and magnificent. Those stars we see, they're part of our Milky Way, just one galaxy among more than 200 billion others in the observable universe. At first glance, galaxies seemed randomly scattered, like butterflies adrift in space. But over time, scientists uncovered something extraordinary. They're woven into a vast, intricate network known as the cosmic web, a colossal structure binding the universe together. Without understanding this web, we can't truly grasp the cosmos. It's not just a backdrop, it shapes galaxies, connects them, and in many ways, is them. It's the universe's architect, and its fate is intertwined with everything we see. The cosmic web is the largest and most vital structure in existence. It molds the universe's form and carves out regions where life can emerge. Without it, stars, planets, and habitable worlds like ours would never have formed. So how did a cold, lifeless cloud of gas transform into this grand cosmic tapestry, filled with galaxies, planets, and beings like us? Every element in the universe has its place in this story. At first, galaxies appeared scattered without rhyme or reason. But eventually, we realize they're linked by an immense, sprawling structure stretching across the void. This is the cosmic web, cosmology's greatest mystery. As astrophysicist Hakeem Aluseid puts it, we can't truly understand anything without knowing how it came to be. To unravel this mystery, scientists peered to the edges of the observable universe, studying light from the earliest galaxies. In 1995, the Hubble Space Telescope focused on a tiny, seemingly empty patch of sky and captured the Hubble Ultra Deep Field. What looked like nothingness was actually teeming with thousands of galaxies. This single image reshaped our understanding of the cosmos, revealing that even the darkest corners of space are alive with light. That minuscule snapshot, no bigger than a grain of sand held at arm's length, showed us that deep space is illuminated by billions of galaxies, each brimming with millions or even billions of stars. The cosmic web itself is made of ancient rivers of hydrogen gas, spanning hundreds of millions of light years. It's the universe's largest structure, a network of dark matter and gas filaments tethering galaxies together across unfathomable distances. Galaxies, stars, black holes, and gas clouds are all interconnected by this web, like highways between massive galactic cities. Astrophysicist James Bullock explains that the cosmic web stretches as far as we can see and took shape early in the universe's life, roughly 13.8 billion years ago. After the Big Bang, the universe was a seething, dense inferno. Ordinary matter, atoms, moved too fast for gravity to hold it together. But dark matter, an invisible substance making up about 85% of the early cosmos, was different. It cooled quickly, clumping under gravity's pull. These clumps created gravitational wells, drawing in more matter. Around 380,000 years after the Big Bang, as the universe cooled further, atoms formed, and hydrogen and helium gas settled into these dark matter structures. These halos of dark matter attracted gas, seeding the first galaxies. Like cosmic scaffolding, dark matter supported the universe's construction and still holds galaxies in place today. Over eons, dark matter filaments contracted, forming threads that linked dense regions, weaving the cosmic web. This network grew for billions of years, pulling in hydrogen gas and lighting up the structure we now observe. Yet, despite knowing stars and galaxies eventually formed, we still don't know exactly when the very first galaxies appeared. It remains one of the universe's enduring mysteries. In 2018, astronomers studied an ancient galaxy called MAX 1149 JD1, home to some of the oldest stars ever seen. These stars ignited shortly after the Big Bang. By analyzing their light, scientists gleaned clues about the cosmic web's formation. But when they examined light from when the universe was just 250 million years old, they were stunned. These stars didn't just contain hydrogen and helium, they held heavier elements forged by earlier stars. That meant star and galaxy formation began much sooner than we'd thought. Astrophysicist Serafina Nancy explains that in astronomy, anything heavier than hydrogen and helium is called a metal, even elements like carbon or oxygen. After the Big Bang, only hydrogen and helium existed. Heavier elements were born in the hearts of dying stars. The brightest stars in early galaxies formed around 250 million years after the Big Bang. Some were nearly as old as the universe itself. Their composition marked them as part of the first generation, though even older stars must have come before. We still don't fully grasp those earliest stars, how they formed or how they sparked galaxies. It's almost like science fiction. From total darkness emerged a vast structure that birthed galaxies. Though we've never seen those first stars directly, physicists have theories. To understand, we must rewind to about 100 million years after the Big Bang. The cosmic web existed, but it was dark, no stars yet shone. Over millions of years, gas clouds linked to dark matter began collapsing. As hydrogen gathered and cooled, it formed dense, massive clouds. When hydrogen is squeezed tightly enough, nuclear fusion ignites, turning hydrogen into helium and birthing stars. Simulations suggest these early clouds were hundreds of times heavier than our Sun. The stars they spawn were unlike anything in today's universe. Modern stars top out at around 70 to 100 solar masses, but the first stars may have been up to 1,000 times more massive. A star that size in our solar system would have swallowed Jupiter whole. A star's lifespan hinges on its mass. The bigger it is, the fiercer its gravity, the hotter its core, and the faster it burns out. The most massive stars live fast and die young. These early stars were like cosmic rock stars, brilliant but fleeting. They didn't live long enough to build galaxies, but they set the stage. When they exploded as supernovae, they scattered heavy elements like carbon, oxygen, and silicon into space. Today, our galaxy sees a supernova every few years. Back then, titanic explosions were constant. From that destruction came creation. These blasts seeded space with new materials. Around 200 million years after the Big Bang, gas enriched by the first stars made it easier for new stars to form. Heavy elements cooled gas clouds faster, aiding star birth. These newer stars were smaller, more stable, and formed in greater numbers, giving rise to entire galaxies. This was the dawn of young galaxies. But the process wasn't straightforward. As galaxies emerged, so did cosmic forces that devoured metals, like parts of the cosmic web and dark matter itself. Around 13.5 billion years ago, stars began forming within dark matter structures. But how did these structures become the galaxies we know today? Scientists believe destruction played a role in creation. In October 2020, astronomers found a structure dating back to 900 million years after the Big Bang. It held a supernova, a massive black hole, and 6 galaxies feeding it via the cosmic web, like a cosmic pipeline. Supermassive black holes are among the universe's most powerful entities, weighing 100,000 to 10 billion times more than the Sun. They consume everything, even light. For years, scientists puzzled over how they grew so massive so quickly. Ordinary black holes, born from collapsed stars, are far too small, just 3 to 1,000 solar masses. Now, we understand, supermassive black holes were fed by rivers of hydrogen flowing through the cosmic web. While stars formed on one side, black holes devoured star-making material on the other. It seems destructive, yet most ancient galaxies, including ours, harbor a supermassive black hole at their core. Take Sagittarius A, the Milky Way's central black hole. It's 27 million kilometers wide and 4 million times the Sun's mass. Despite its chaos, astronomers found 800 gas clouds within 1,000 light-years of it, 30 of which were actively forming stars. Which was surprising, like finding baby lambs in a lion's den. Though star formation happens more easily in quiet regions like near Earth, it does happen even in extreme environments like near black holes. The early cosmic web must have had similar harsh conditions, yet from there too, galaxies began to form. These new pieces of evidence reveal that stars can be born even in such extreme conditions. The reason is that gas and dust orbit around a black hole in an accretion disk. Because of the extremely high temperatures, gas clouds separate from the disk and drift off into space. That gas then cools rapidly and contracts to form new stars. This is the most active stellar nursery in the universe. It seems like these dangerous environments would prevent stars from forming, but in reality, they actually help in creating new stars. So, what we think of as the destroyer of stars is, in fact, also their creator. Where streams of the cosmic web meet, matter accumulates, and the nearby supermassive black holes consume it. Around them, new stars form, and from them, galaxies emerge. It's possible that something similar occurred in our own Milky Way within the streams of the cosmic web. New research suggests that these galaxies are formed out of destruction and chaos, and without that, our existence might not have been possible. The newborn universe was a dramatic place. Stars were forming and dying rapidly, even near supermassive black holes. New galaxies continued to emerge in the cosmic web. But what were those galaxies like? Scientists believe that galaxies formed from collisions. A little chaos in the universe is necessary, like how you have to break an egg to make an omelet. Even for a chick to emerge, the egg must break. In the same way, the destruction of a galaxy can also signal the birth of something new. Some amount of upheaval in a galaxy is necessary for new stars to form or for black holes to grow. That's why the eccentric Nancy says this universe was made from things colliding and falling apart. The Hubble Space Telescope has observed many disturbed galaxies, showing signs of massive collisions and destruction in space. Galaxies never stay still. They are constantly changing, crossing each other's paths, colliding, and then merging. We know galaxies collide today, but what about in the early universe when the cosmic web was forming? Astronomers studied a peculiar merging galaxy called Himiko, which formed 800 million years after the Big Bang. The light from 3 regions showed that new stars were continuously forming. Upon closer study, scientists found it contained 3 small galaxies that hadn't fully merged. Scientists call these young star systems proto-galaxies. The stars we are made of came from the collisions of such galaxies. Proto-galaxies often collide, and these intense collisions lead to the birth of new stars. They contain large amounts of gas, and when they merge, their gases collide, compress, and form new stars. This process of collision and merger can go on for hundreds of millions of years, eventually giving rise to a new, full-grown galaxy. Now imagine the universe 500 million years after the Big Bang. Compared to today, it was smaller and more compact. There were many proto-galaxies, and because of their high density, collisions were more likely. Where the streams of cosmic gas met, there was more matter, and new galaxies formed. When these small proto-galaxies collided and compressed the matter-rich regions, many new stars were born. These collisions sped up the star formation rate and increased the size of galaxies rapidly. You might think such collisions would destroy the original galaxies, but observations show that even in violent collisions, remnants of older galaxies persist. Scientists studied our own galaxy and found evidence of a collision from billions of years ago that triggered the growth of the Milky Way. One such group of stars in our galaxy is called the S collection, which exists at the outer edge of the Milky Way and behaves differently from the other stars, likely due to an ancient merger. After around 1 billion years since the Big Bang, the dark matter-built structure of the cosmic web began to glow. Metals and dust started moving along its filaments. Even the outer regions near supermassive black holes saw new stars being born. Galaxies started colliding, and new light began to appear across the universe. Yet the biggest mystery remains: how did our Milky Way survive and grow amid all this cosmic chaos? Careful observations reveal that the birth and death of things in the universe are deeply connected to the structure of the cosmic web. 13 billion years ago, in the midst of the newly forming streams of the cosmic web, a proto-galaxy was born. This eventually became our Milky Way. Whether a new galaxy will survive or not depends on many factors. In 2020, scientists captured an image of a beautiful galaxy that formed 140 million years after the Big Bang. Analysis of its light revealed that it was a starburst galaxy where new stars were forming rapidly. It seemed that some galaxies in the early universe were forming stars at an extraordinarily fast rate. But how is this possible? Scientists believe the answer lies in a mysterious structure responsible for channeling gas throughout the universe from the beginning, the dark matter framework. This structure holds the universe together. But understanding this invisible structure isn't easy, because dark matter cannot be seen directly. In 2021, an international team of researchers studied the dark matter near us. They observed how it affected light. When light passes near a massive object, even if invisible, like dark matter, it bends. The team studied light from 100 million visible galaxies and tracked how it curved, learning to observe the dark matter behind stars. At the same time, they discovered new connecting tunnels between galaxies. These new dark matter structures revealed that our universe is like a maze, with hidden pathways between galaxies. Galaxies tend to form where cosmic web streams intersect most strongly. This may explain why some early galaxies formed rapidly. But there's another side to it. The cosmic web gives life but can also take it away. When scientists studied galaxies connected to multiple streams of the cosmic web, they noticed something strange. Star formation was decreasing. Why? Because where the cosmic web delivers too much gas, young galaxies can't handle the flood. It's not just stars that form. The central supermassive black holes also start growing rapidly. For young galaxies, this can be deadly. The black hole consumes a lot and releases intense energy and hot winds. Researchers found that galaxies connected to many cosmic web streams can grow faster, but those connected to too many were the first to die, just like plants die from overwatering. Perhaps our Milky Way was lucky. The cosmic web determines how long the galaxy survives, and thanks to it, our galaxy became so beautiful. But now, the role of the cosmic web is about to change. An invisible force could destroy it. The cosmic web formed the universe in an organized way. Its gravitational pull from dark matter helped galaxies form and evolve. But that growth eventually ends. No structure larger than galaxy clusters can form. Something is now preventing further creation in the universe. To understand this, we must go back in time to the moment of the Big Bang, 13.8 billion years ago. A small, hot ball of energy cooled and expanded, splitting into normal matter and dark matter. But something else also formed, dark energy. We know very little about dark energy, but it has always been a part of the universe. One theory suggests it was never created. It's simply part of the laws of physics, eternal and ever-present. Many assume space is empty, but the discovery of dark energy suggests that space itself may have pressure, a force that pushes things apart. The universe is far more fascinating than we imagined. Initially, dark matter was everywhere. But as it spread out, empty spaces started forming between the streams, and from these, dark energy emerged. The strangest thing about dark energy is that its density remains constant. So where there's more space, there's more dark energy. It pushes against the cosmic web and creates vast voids in the universe's structure. Over billions of years, the gravitational hold of dark matter has weakened. The threads binding the cosmic web are breaking. And as the cosmic structure collapses, galaxy formation is coming to an end. But the most dramatic time is yet to come. Not only is the universe expanding, it's expanding faster and faster. As dark energy increases in those regions, the entire cosmic web may begin to disintegrate. In the end, the universe will become empty and silent. Even the closest galaxies will drift so far apart that they'll appear as faint points of light. Then, darkness will return to the cosmos. The universe was born with a bang, but will end in silence. Without the cosmic web, nothing interesting would exist in space. It's the largest structure in our universe, responsible for galaxy formation, star creation, and enabling life. Without it, we wouldn't be here today, talking about it. By understanding the cosmic web, we begin to understand dark matter, dark energy, our past, and our future. Everything we know about the universe is deeply connected to this network. It's amazing to realize that the universe we see today, with all its complexity, began forming during its earliest moments. And it is because of that formation that life like us exists, life that can observe, question, and try to understand this grand cosmic story.